Alright, let's see if I can start a new streak. I was thinking about yesterday's problem. I'm almost certain it's dynamic programming, but I didn't come up with a solution, or I didn't work on it that much more. Anyways, left and right sum differences, easy. We give a zero index integer array of size n, define two arrays, left sum and right sum, where left sum at I is the sum of the elements to the left of the index I in the array's nums. If there's no such element, is the sum of the elements to the left of index I in the array nums. If there's no such element, left sum. Okay, I skip the indexes. I'm not sure how. Right sum is the sum of the elements to the right of the index I in the array nums. If there's no such element, return with right sum of pi equals 0. Return an integer array of answer of size n, where answer pi is equal to the left sum at I minus the right sum at I. So at 0, nothing's still left. It's the absolute value, okay. And then from 0, 4, 8, and 3 are to the right. I see. So it's 15, 0 minus 15, absolute value. And then 10 minus 11, so it's 1. 4 and 3, or 10 and 4, 14 minus 3 is 11. Okay. So I think you want to get the sum of all the values first, using sum, because that's pretty fast. And at that point, you keep a running partial sum up to the index I, and the left side will be that partial sum, and the right side will be like the total minus the partial sum minus the total minus the partial sum minus the current index value, something like that. So let's say answer is going to be an empty array. I'll just append to it. N is the length of nums for every index k in range n. I'll say partial sum is going to be 0. So the right side partial sum is going to be equal to the total minus nums at k. Total minus nums at k minus the partial sum. And then the answer is going to append the absolute value of the right side minus the partial sum, or the partial sum minus the right side. I guess I can call this partial sum the left side. I wonder if there's a faster way of doing this. And then the left side now increases by the nums at k. So initially after 0, right is going to be total minus 0 minus 10. So it's going to be 15. 15 minus 0, absolute value. Okay, I think that's fine. Does this work for the last index? Last index is here. Left should be inclusive of those values. Total minus nums at k minus left. I think that's right. Okay. I don't think I actually, this should be appended. Whoops. Answer, append the value of the absolute value difference. And it works for example 2, even though I really didn't think about it. Okay. Well, I'm pretty sure there were definitely other ways of doing this. So summary, use a for loop to go through all the indices of the array. Keep a running partial sum, I'll call it left, as you go through those values from the left side. Also pre-compute the total. Find the sum of the array. Right side at any given index can be determined directly from total minus kind of index of this current value, or array at this current index, minus the left side, and then append to the answer array the absolute value of the difference between the left and right partial sums. Alright, time complexity is going to be O of n, where n is the length of the array, as you have a single for loop which will iterate over all the indices, doing constant work at each index. Space complexity, that should be O of 1, since no extra space no extra space is needed, the answer array is not included within that space calculation.